Hey, welcome everyone. Thanks for joining the webinar. I'll give a couple of more minutes for the people to join. Maybe I'll start at 10:04 Pacific. We'll give a couple more minutes to get started. All right, let's get started. Thanks everyone for joining. Welcome to the webinar. Let me quickly introduce myself. This is Sricharan Mahavadi. I don't want to bore you guys with my bio. It's there in the webinar details. So I'm a solution architect and principal DBA from Robin.io. Along with me, I will be co-presented by Charles Hart, who's a senior database architect from Sabre, who's a customer of Robin. Thanks for joining us, Charles. So in this today's webinar, I would cover on how we have transformed enterprises to build their on-prem Oracle RAC DBaaS solution and how we enabled in the Oracle ecosystem to be modernized. For those who are new to Oracle, let me give a quick recap. Oracle has been a de facto standard for running enterprise-grade relational database system, and it's known for its reliability to run any mission-critical business applications. Almost every other applications that we run on, that we use on a day-to-day basis, will have some presence of Oracle under the hood. All right. So if you take a close look of what modern business demands, right? Modern business demands for everything to be quick, They want new products to be launched, new features, a quick time to market, and faster delivery with the lower cost, right? So we all know that DevOps has been the secret mantra for faster delivery, right? But what does DevOps mean for database community? What does DevOps means for DBAs? If you look at what does it mean, right? The database developer needs faster provisioning and quick ability to have quick clones and for dev test and for their development activities, right? And the QA wants to quickly break things and raise the bugs so that it can be improvised efficiently. The operations want to scale with the frequency at which they are getting the new application provisioning requests or ability to deliver on their promises with respect to clones and ability to restore and roll back. So while doing all these things, IT also wants to control their costs and be manageable with respect to IT administrative overhead and the time to delivery, right? So based on the customer feedback and the research from the developer community, we identified that the top database management ecosystem challenges are, as we know, provisioning new systems has been very painful, and there's a lot of turnaround involved in the process of provisioning and deprovisioning, and there's multiple teams involved in the whole cycle. And also business demands for as the business grows, it demands for scalability of the infrastructure, right? So the organization has to scale with the growing business needs. Also, some of the challenges with respect to, hey, I need a quick clone of the database so uh, I can perform my enhancements, or I can test this application features, right? The ability to quickly perform database cloning and restore has been a challenge for most of the database organizations today, right? To achieve the business continuity through one-click operations, or to achieve the business continuity and the costs involved in maintaining the redundant infrastructure components and not efficiently utilizing. So these has become very painful process for the IT managers and the IT engineers, database engineers. So, and also there's a lot of pain and inefficiencies involved in managing large deployments of enterprise RAC deployments or enterprise applications, right? So considering these challenges, right, if you take a close look on a traditional provisioning model, which is considered to be very slow, if you look at there are multiple parties involved, um, let's say if a business user requests for a new feature or a new product to be added, right? So it goes to the technical developer who wants to develop, and he raises a request to create their own application or a database, right? So it goes through a set of approval process, and then goes to the DBA manager. DBA manager assigns a DBA to perform to ask for to provision the database, and the DBA internally requests has to work with the different teams like storage team, network team, Linux team, to set up the associated hardware network and the OS version required for. And once the infrastructure systems are ready, the DBA will then configure the necessary database installation or the application installation, which would then be handed over to the developer, and that's when the developer would actually kickstart their actual productive development activities. So the whole process is quite slow and involves multiple parties, multiple SLAs, approvals, workflows, and all that stuff, right? The modern DevOps world wanted everything to be really quick with the latest data, and want to be self-serviced, right? The QA wants to have copy of the dev so that they could continue to identify the bugs and break things so that the quality of the product can be delivered better. But the reality is it takes several days or even weeks to actually get the infrastructure ready and applications to actually deliver, right? In this webinar, I would focus primarily on Oracle RAC. So if you look at if you take a close look at how we provision an Oracle RAC system today, right? The DBaaS has to identify and procure the hardware required, and a lot of coordination and planning is involved. A lot of multiple teams and administrators are required for getting different infrastructural components lined up. We have to ensure the rack deployment has proper OS versions, proper OS RPM packages installed, and you have the network teams ready to plumb their public and private network interfaces for the Linux servers, and you need to work with the Windows team or the DNS team to enable to provision the scan IPs and related IP addresses, along with storage team to ensure the storage is also lined up. So once all the infrastructure components are in place, that's when the DBA will take over, validate everything, and then start working on grid infrastructure and database binary installation and so forth, right? So once this whole process is completed, that's when the developer actually kicks in and start working on their development activities. So the whole process is so cumbersome. And with all these challenges in mind, it has become a nightmare for the IT managers and DBA teams to deliver on their promises. So with these bothersome issues in mind, this actually prompted the need for a solution like Oracle Database as a Service. So while IT and QA wants self-service, rapid provisioning, simplified management plane, and quick turnaround of their applications, and be able to quickly and swiftly clone and restore, test and fix and break things. And IT wants to maintain control, have a standardized platform with error-free, consolidated, and lower administrative overhead and costs, right? While Dev and QA want these benefits, the business also get the best out of it by achieving the faster time to market, reduced cost, and having the platform future-proof, right? And this is where Robin would help, right? If you look at what Robin is a software-only platform that would help in automating the deployment, scaling, and performing lifecycle management of enterprise applications on Kubernetes. I would say using Robin, one could enable enterprise to build as a service solution for a single application or a set of applications or a database or a pipeline of your database and applications together in your own data center or any public cloud of your choice. So if you take a high-level look, right, so how Robin would achieve this, Robin is tightly integrated with Kubernetes as the core compute orchestrator to deploy Docker-based and LXC Linux-based containers. It has a built-in enterprise-grade storage stack, which is a scale-out block storage with enterprise-grade features like snapshots, clone, replication, encryption, compression, thin cloning, tiering, and so forth. Along with that, Robin also has inbuilt networking stack, which uses OVS, Calico, and other standard networking technologies. So the unique thing that Robin has is the application management layer. So the application management layer is tightly integrated with storage, Kubernetes, and networking component that will allow to enable any application as a service workflow to the end user. So using application management workflow, you have capabilities like having the ability of having the hook script provision, which would enable the customer to customize their application deployment process and lifecycle process in the way they want. So you can define your own post-clone, pre-clone, pre-snapshot, post-snapshot, post-create application hook scripts so that you can customize your application lifecycle behavior based on the changes that you put in those scripts. If you take a little closer look on how Oracle RAC software has been deployed on a Robin software stack. So as I mentioned in my previous slide, Robin has a distributed scale-out block storage that discovers all the resources of the underlying Robin host infrastructure. And it carves out raw devices and presents it to the container that is orchestrated by the Kubernetes. Right? And so Robin configures the public. Robin's network stack will enable Robin to configure the public and the private interconnects for the Lexi container, and will allow the containers to have multiple NIC interfaces so that Oracle RAC infrastructure could be safely deployed. Right, and Robin's RCM components and the Kubernetes components would help in orchestrating the LXC-based containers and also enable the application as a service experience for the end user. So today I would be we'll be having Charles Hart from Sabre, who's a customer, and he'll explain how Robin helped us transform their Oracle RAC ecosystem and enable as a DBaaS solution, and how they were able to have 400 Oracle RAC databases managed by a single Robin cluster. As you know, Sabre is a technology leader in travel and hospitality domain, and I will hand over. Thank you, Charles, for joining us, and you can take it over from now.
Oh, okay. Let's go to the next slide then. Basically, what he was saying is true. I mean, Sabre basically is a technology company behind almost any travel, as far as planes, hotels. I mean, every seat that's booked, every pilot that gets on a plane, every stewardess, all that is booked, and most of it is booked through Sabre, not totally, but you know, I mean, they're one of the biggest ones that's there. If you're making reservations, you're probably in the background going into Sabre through you know, another company, and it's going to go into Sabre, and it's going to look up and tell you the price that the hotel wants to book, or the plane wants to book, or what seats you're going to get or open at that point. Almost any of that goes through there. As you can imagine, since they're a worldwide company, how many billions of events come through, you know, because I mean, when you're looking for a seat, you're probably one of, you know, 150 people at the time looking for exactly the same seat for the exactly same airline. We are, because of that, all our systems, all our Oracle systems are RAC deployed, because dependability and stability is one of our biggest points, and so we've got to be up 100% of the time to get the information that you're requesting. Anyway, let's go to the next slide, Sricharan. I mean, as you can imagine, booking, where it said that we had 400 racks, that's just a small portion of what we have. But, you know, for every rack, you had 2 physical machines there that were, built exactly the same. So you had a lot of hardware. You had to procure the things. You had to work through the, getting the machines, and then getting the network people involved, getting the Linux people involved, getting the SAN people involved. And all that is, to go through and get everybody involved and get it all done quickly usually didn't happen very, very quick at all, sorry. And, then once you had it up, you had all the people that had to administer the overhead and go through the whole system. Every part of it was slow and very hard to work with. Basically, once we got Robin, it's a lot easier and faster to go ahead and get the everything provisioned, and we had the ability, since Robin is a HA system, that the Robin system itself, we can more or less move we can move the containers or do whatever we need to as fast as we can. So the building a rack is very quick for us, and it's very easy, to move it from one system to another if we need to do that. If we have a bunch of systems running all in one, we can move one rack or one part of the rack to a different system to make things work faster and quicker. Anyway, but with Robin, everything became a lot quicker. We could just go in, put a couple of required fields in, and just do one-click rack provisioning. Everything was there inside Robin, so it's very quick to manage it. You need to scale out, you can just go into the system and say, this is a 2-node rack, we want it to be 3 nodes or 4, or we can scale it up, scale it down if we need to. We can do snapshots or take backups. Basically you can just put it in real quick, and it's very quick to take a snapshot, just as quick to recover. You have the capability of doing clones, which are really nice, which are, say that you want to go test something. You can take existing system as it sits right now and say, I want to clone that over to a different system. So you can make a quick copy of the system and build it out very quickly, and then you go test what you need, and you can blow it away once you're finished. And so it's very quick to go and do that. I like CLI more, and so it's very quick for me to go in and write a script to go in and do something against all systems or whatever I need to. It's very easy and straightforward. One of the reasons that we probably went with Robin versus the other containerized systems is that they have things called hooks, so we can customize almost anything we want when we're starting up system, or as far as that goes, creating a system. We can actually go in and go into the hooks and say, I want to do, I want to create this, I want to have this happen on creation, I want to have this happen on startup or shutdown. And that we didn't see on any other systems other than Robin's that gave us that flexible capability that, you know, on all the hooks to allow us to do what we wanted to do. Because of that, we can turn things around very quickly and set up systems. Instead of building, you know, like I said, 2 or 3 node racks and having hardware for each one, with Robin, we can take machines that they don't even have to be the same hardware or anything, or it's even the same versions, and we can go out and put a new machine in if we need to into Robin, and, you know, say, hey, we want to use the CPUs off of this, and we want to use the storage off another system, or we can use it all off the same ones, and it's very easy to put that in. Because of that, we can do things a lot quicker than we ever were able to in the past, and people can request a new rack, and we'll just go out and put in a few selected things in and say, build a rack, and it goes out, pulls everything that we need to into the system and builds a rack for us. Go ahead, Sri. We'll go to the next slide.
Okay.
Oh, sorry. We've got, now we started off, you know, with the racks, multiple racks. We were on the, I'm sorry. What we had is, you know, like I said, we had physical hardware that was built just for one rack instance. Now we can take machines, throw it in there, put it into Robin, and we can build multiple racks on that same machine. Because what you'll find out is most of the time your machines aren't being used that intensely in the CPU. Well, because you have the capability of putting multiple ones on there, you can push the CPU where to work harder for you. We have, like I said, we have 400 right now into Robin, and we're going to be, that number is going to be going up substantially because of the things that we have coming. But yeah, I've already talked about the deploying the scale and snapshots and all that. So I'm going to go ahead and turn it back into.
Okay. Hey, thanks, Charles, for sharing your experience on Robin. Thanks a lot. Okay, so I'll take the next part. I'll go over how we transformed and how we can leverage Robin to modernize your Oracle infrastructure, right? So if you look at what Robin is, right, just to kind of recap on the same thing, Robin is kind of a distributed platform that discovers all the OS resources on the bunch of hosts, and it will kind of create a private cloud on your in your data center, or it could be on your cloud. So with that, having said that, it knows where each resources of each host are, and it keeps track of the inventory of the CPU, compute, storage, and the application resources. With that, having now that Robin has a complete control on storage, networking, and application layer, it would essentially make your deployment go almost like 10 times faster, or even more, right? So if you consider deploying an Oracle RAC infrastructure over a period of 1 week versus having it deployed in minutes, right? It would be probably around like 35 or 40 minutes is when you kind of get your Oracle RAC database up and running. And if you want to have if you want to have a clone, right, for your dev and test, Robin would help leverage Robin's integrated infrastructure to kind of take a storage level snapshot and apply the application level configurations. Because it's all tightly integrated, it will make your refreshes timeline rapidly reduced, right? You can have snapshots scheduled for every day and retained for a week, and then it automatically gets deleted. So all those things are inbuilt in the Robin platform. And since Robin has complete control on the IO path and various other OS resources, it can give you a better consolidation experience and has a complete quality of service and guarantees the deliverable timelines for the end customers. And thereby, the IT managers don't have to worry about working hard over the nights and getting the infrastructure ready and in line for to deliver their customers, right? With the growing business needs, Robin would help in scaling their databases, both up and out. You can scale your resources for the existing system, as well as you can scale horizontally, add multiple nodes on the fly. So Robin would do the standard Oracle addition procedures behind the scene, but Robin would know your application topology and ensures that it uses the same set of infrastructure for the host that is being added. So I'll go over little detail over the next slides. So Robin has inherent resiliency, which would enable you to do automatic failover, and also Robin has a detection method wherein it detects if the app is healthy and takes a certain action as it is defined. So that will help in reducing the manual intervention in case if the database were to go down for some reason. Robin detects that and restart the application as however we defined in the hook scripts. So Robin is completely RBAC enabled. It has a role-based access control, which enables you to run in a multi-tenancy platform kind. And also Robin has complete API support, which you can seamlessly integrate with any of the third-party workflows like Jira, ServiceNow, or any of your workflow system. Right. I'll take a deep dive into each of these, and then we'll go forward. So if you look at the self-service provisioning, right, what you see on the left side is how you see. So for Robin, Robin is not just defined for Oracle as such. You can essentially deploy any customized application, right? So what you see is a kind of app store kind of experience. If you click on Oracle, it renders you a page with a set of predefined values and user inputs. So these the page what you see here is essentially rendered from application package or application definition manifest we call bundle, and the manifest defines how the application topology needs to be deployed or structured. So if you look at a typical Oracle RAC deployment, the moment you click on the App Store on the left, it opens up this page, and all we have to do is provide the application name and the subnet to choose for the IP pool, subnet to choose for provisioning your public IP and a private IP, and define the compute, memory, and number of instances that you want to deploy. Robin, since Robin is tightly integrated with its own scale-out block storage, it can pull out the raw devices and present it to the containers that we wanted to set up for RAC. If you look at other options, right, like you can say either app protected, or you can have the storage level replication factor enabled. Because Oracle ASM has its own redundancy, what we see here is we gave the control back to the app to manage the replication. So if you were to select replication factor, then you can also have a choice to set your fault domain so that in case of any disaster, you can always use the replicated copy. Right, and along with this, there's a bunch of other user inputs, like the passwords, what would be the database name, what would be the different options, and all these values are customizable. So the customer can define their own bundle, and based on these inputs and the variables that we give in the user input, that these parameters are passed to what we call as hook script. So the hook script essentially takes this parameter and deploy the application as mentioned in the bunch of in the bundle scripts. So, right, okay. Sorry. Okay, this is the same thing. If you look at the application, it talks about the infrastructure application, and based on this parameter and the user inputs that the customer provides, based on that, the hook scripts will execute and perform the deployment logic that is there in the hook scripts. Right. If you look at how, if you look at the traditional way of scaling out your applications, so if you were to make a two node cluster to 3-node cluster, it takes you for a ride. There are multiple manual steps involved, multiple teams involved to get things lined up for you, and a lot of manual and error-prone processes are involved, and ensure that node is appropriately added to the existing cluster, right? Considering all these complexities, right? If you look at how Robin would allow you to scale out or scale in your cluster, is just by one click. If you have, assume that you have two-node Oracle RAC cluster, and you would like to extend out or scale out your 2-node to maybe 3-node or 4-node, right? So all you have to do is select the scale option and increase the number of instances either from 1, 2, or whatever, how many ever you want, and as long as the underlying infrastructure supports, that must be fine. So using Robin, it doesn't have to be on a different physical server. You have a fine-grained control. You can also spin Oracle RAC from the same base host. So you can have 2 containers running from the same base host, though that's not recommended, but yeah, you can do that. So similarly, we can also scale down. So we can reduce from 3-node to 2-node. So which would essentially go back and run the hook script, which essentially behind the scene runs a standard Oracle APIs or standard Oracle command line procedures. So this allows you to have extreme elasticity for your growing business needs, and also you want to swiftly ensure that you properly are utilizing the hardware resources when you want. In case of demand, you can scale out, and if you do not want, you can always. So that elasticity is just a few clicks away for you. So this is, I mean, this is the same thing. So coming to refresh, right? We all know the importance of the cloned environments on day-to-day basis. As being in the DBA community, you often or very frequently get requests for spinning up quick database clone for several reasons, right? Could be your analytics wants the real-time data for its decision support system, or you want to test some Oracle given patch, you want to have your UAT things progressing, being worked upon, or you want the QA to kind of work on the fixes that the developer has put in. So those kind of, so there are several various reasons which we all know. I'm not going to go over those things. So with all these things in mind, right, so there are several numerous methods to kind of perform the clone and the refresh activities, which includes a standard RMAN based cloning, snap based cloning, export, import, and taking all the hard backups, and there's a lot of hardware requirements involved, manual procedures involved. It's a time-consuming and very procedural. And there's a lot of storage requirement. You might have to have multiple hardware required, a lot of storage required in the whole process, right? So if you look at how Robin would simplify that, is so Robin essentially is based on copy on write, redirect on write technology, the storage stack. So it makes use of the space efficient snapshot, and it takes a snapshot of not just a specific volume or the entire application. Let's say if you have a composite application with a database in the backend and application stack sitting in the front. So with Robin, you can essentially have both application and database snapshot taken together, because Robin is tightly integrated from app to the disk to the block. So so with that, if you want to take a snapshot of the entire application, Robin knows that these are the volumes that are mapped to this particular application and database. So let me go ahead and take a consistent point in time snapshot of that application. So when you take a snapshot and perform a clone, so Robin knows the configuration of your application and database, and then it presents the similar topology to the cloned instance, and it presents the same disk. Thereby, any change, you actually do not have to allocate special additional storage for your clone instances. It would still use the same storage. So the amount of storage consumed would be only the additional blocks that are written to the clone environment. Thereby, it will radically save a lot of storage space consumption. Right. So you can take snapshot if you want, or you can also schedule and retain it to the number of amount of retention period you want. Right. And because Robin is aware and of the storage stack, so it can either you can do a thin clone, or let's say if you have if one of your developer forgets to makes a mistake and delete some table, right? You can always go back in point in time, which would put your application and the database, or the database together in that snapshot time. So this would go handy if you are doing a lot of bug fixes, you want to try out and want to jiggle around with the instances in previous state, right? And all of this snapshot clone would happen within minutes. A snapshot would be seconds. Okay. So if you, same thing, it's little animation here. So if you want to take a snapshot of your Oracle application, it takes the snapshot of your storage and then spins out the LXC or Docker-based container and attach the volumes, and you can start using that. Let's say if let's consider, as I mentioned, right, it only uses the fraction of storage that is actually being the amount of block changes that have been applied on your clone instances. If you look at having multiple clones of your source system, you can essentially save a significant storage penalty because all your reads would still go and read from your source volumes. So if you look at from the business continuity and HA side of it, so Rob, if you look at the current standard, so business continuity is critical, and a lot of enterprises have active passive cluster setup and a lot of redundant infrastructure and a lot of operational overhead is involved in maintaining them. So this storage replication, and you have binaries sitting on your DR site, and all kind of those things, right? So there's a lot of infrastructure that has been put in and is not is being heavily underutilized, and numerous tasks are involved, right? So with Robin has inherent resiliency that would allow you to that would constantly monitor the host health and ensure that if the desired host health, if the host health is unreachable, or if the host goes down for some reason, it would swiftly relocate the containers across to other surviving Robin hosts. Right. So what you see here is essentially you have app sitting here. If the host goes down, Robin would swiftly relocate the containers onto surviving host. And it takes care of the storage and networking part dynamically. That has the same network stack and storage to it. So if you look at the challenges involved in consolidation and managing large enterprise databases, there's most of the traditional database management strategies were around having a siloed infrastructure, isolated and dedicated in their own infrastructure, and a lot of teams involved and time involved in managing and managing those things. And also there's a lot of there's a heavy penalty and underutilization of the system resource and the human resources there. So there's most of the companies has a constant effort in exercising to meet the better consolidation and optimization when it comes to efficiently utilization of their hardware resources. Yet they could not still be able to efficiently get the better use of their hardware resources. So with Robin, right, because Robin is a hyper-converged platform where it knows where the storage and OS resources are and what application needs. So it maximizes every opportunity for consolidation and effectively uses its resource management algorithms to put the resources effectively, and you can essentially make every use of your investment effectively by properly utilizing the hardware. So with Robin, because managing large deployments would be can make it as a standardized. You don't have to deal with hey, it works in my server or my setup but doesn't work in your setup. So you don't get into that state, because Robin uses the same image and same set of scripts, and you will be able to deploy the same kind of applications or RAC databases across all the infrastructure when it comes to managing a large number of databases. So you can with Robin, you have complete control on the IOPS, and it can you won't have to deal with noisy neighbor problem, because it can guarantee you the IOPS required for your application landscape. Thereby you don't have to nobody can step into your IOPS limitations. So yeah, it's the same thing that I was explaining. So the quality of service, you can scale your as your demand increases, you can scale your system resources and the container resources. You can increase your CPU memory, and also you can restrict to or you can define your read IOPS and write IOPS capability, so that you will be guaranteed with specific IOPS and you won't hit into any noisy neighbor problem, right? So as I mentioned earlier, Robin is multi-tenant support, and it has a complete role-based access control capability, where you have a Robin cluster that you can logically partition it to different teams or different set of resources, or different kind of applications can go and sit on different set of different pool of Robin hosts. Okay. So you get with Robin, you get a consolidated and a predict for any consolidated deployments, you can get a predictable performance. You can eliminate the noisy neighbor problem, and you have complete control on end-to-end IO pipeline. That can help you enforce the QoS for each app. So Robin is aware of which block belongs to which particular app, and you can have a fine-grained control on setting up those limitations. So as I mentioned earlier, with Robin, you can essentially have a double guard for your rack infrastructure. Even for a single database, single node database, if if your instance is running and the host goes down, Robin swiftly migrates the container and attach the same storage and the networking piece to the other host running on the cluster. So thereby you are along with your rack, you will be having additional layer of high availability solution attached to it. So benefits using Robin's hyperconverged Kubernetes, you can modernize your rack infrastructure. You can make it self-service. You can have a seamless experience for your customers and give a quick turnaround of your rack database deliverables. Robin supports on-prem and on any cloud, and it will give you a guaranteed SLA, error-free, consistent, standardized, and consolidated deployment experience, and increase the utilization of your hardware resources. Thereby, it will help you save a lot of cost and administrative overhead. So your development team and QA team could be more productive. They can work on the actual business features instead of waiting for the DBaaS to turn around and deliver their systems for them. So quick debug experimentation could be possible using Robin, and thereby the quick time to market can be achieved, and business can innovate quicker. Okay, let me quickly take you to the UI. Let me see. So we have about 10 minutes. I'll quickly walk you through. So what you see is a Robin dashboard. So as I mentioned, Robin is a distributed platform. I have a 3-node Robin server setup, so Robin discovers the CPU memory and storage, and it could be the number of nodes can be added, and we can scale as we want. The installation would take around 10 minutes for any node to get added. So what you see on the application side, is we call bundles. So this is the application package. So these are some of the applications which are present on my setup. We have several of those things. In fact, you can build any of your homegrown application into a Robin bundle. So we have a dedicated bundle building training, which will allow you to explain how easy it is to build a bundle. So bundle is essentially a manifest definition file and a bunch of lifecycle scripts that would define what script should be done at what time. Okay, let me go to Oracle RAC here. So like what we have seen in the presentation. So you can essentially, in order for you to create or deploy an app, RAC app, I would say demo 8 RAC, and then you choose the public network. So you can set up your IP pools. You can set up a set of pre-provisioned IPs to Robin, and Robin will once you register the set of IP as IP pool to Robin will manage those IPs for you. And during the deployment process, it picks one of the public IP here and one of the private IP, and it can spin 2-node, 3-node, or any number of nodes that you wanted, right? If the underlying infrastructure supports as long as the resources are there. So you can have Oracle ASM based replication, or you can also say I want two-way disk replication for this one, and I want my fault domain to be either a host or disk or on a different rack. So each disk, Robin is supports compression, layout, encryption, workload, and you can also have a choice to select what kind of workload this particular volumes are they. Do you want to have this volume sit on a dedicated drive so that it can give you a full spindle throttle to that application, right? And you can also define set of the user inputs. So these are the specific inputs that you can give. That can be passed to the application hook scripts in the package, and the scripts basically uses these inputs and run all the necessary Oracle lifecycle operational logic. Essentially, in this case, it reads the database and all those things, and behind the hood, it goes and installs CRS database and creates the database and make the Oracle RAC up and running. So once all the inputs, mostly all the inputs are pre-provisioned or predefined, you just have to give the name, and all you do is you can either save a template, you can save a specific configuration and make a t-shirt size template, or you can directly click provision. When you click provision, basically it uses this resource definition and carves out the necessary OS system resources from underlying infrastructure, and it boots up with the Oracle container image, and then installs CRS database, and brings up the database and makes tap and running ready for you. So let me quickly, I'm not clicking the provision here. It's going to take around 35 minutes of time. So I'll show you one of the database here, which I've deployed. So it's a 3-node Oracle RAC. If you look at, so it has the storage pieces that that Robin has carved out and attached to it. And I can quickly take snapshot, and I can configure a clone. So if you look at my 2-node rack and see, I can say I want to take a thin clone of this snapshot. Once you get a thin clone of the snapshot, it asks for what is the clone name, and you can say clone 3 DB, and then it uses the same storage stacks. That's why it's grayed out, and you can give the IP pool, and if you want, you can change the database name from clone DB. And once you quit, and we have placement policies where you can say my containers, I wanted to go on to third host of the Robin or second host of the Robin, or you want to, you can restrict saying that no two containers should sit on the same host, right? So once you click clone, it uses the same storage stack, and then it spins out the it creates all the cloning procedures and brings the application up and running. So all the functions, if you see that the clone, this is the clone based out of this one. Let me quickly take you to the clone. So if you see the clone app, this is a clone app which is running, and these are the resources that are designed. And you would just connect to the container like the way you connect today to any VM or physical server. You do the SSH service runs on it. So all the operations that you see here are CLI enabled. So you can also run Robin CLI commands to look up all the things that we're checking on the UI. So you can also set the host in maintenance if you want to perform certain specific operations on this, so that no Robin Robin resources would not be placed on this particular host. So this is a 3-node host. I have I have these are the applications. Robin app list, and if you see it uses this is the master and this is the clone, and it tells me what are the resources here. So I'll stop it here with respect to time, and then we'll take up on the questions if anyone has. Let me look at the questions. Okay, so I have a question. How can we add customized deployment scripts? Okay. All right. So let me quickly take you to how a bundle look like, and where we can go and change the script, right? Robin. So these are all some of the bundles we have, and as I said, bundle is essentially a manifest definition file and a bunch of lifecycle scripts and the icon that we see in the UI. So this is the bundle. So we have application and vnode hook scripts that will allow you to add, change any lifecycle behavior during the application process. So if we can perform validate, by which it will validate whether the user input given is correct or not. So Robin supports any script, could be Ansible, Python, Bash, and it takes all the user inputs and pass these variables to the hook scripts, and you can write the logic in the hook scripts and customize as you need, and that will allow you to extensively use a Robin bundle to perform anything of your choice. I have another question. Can this be deployed using our existing ticketing workflow? Yeah, as I mentioned, yes, you can. Robin is completely API based. You could integrate with ServiceNow, Jira, or any third-party workflows. Okay, how can we monitor Robin containers and host performance using Robin? Yeah, so coming to performance, right? So you can check containers performance either from Robin UI. And Robin infrastructure has, it will give you the nice graphical representation of the performance on the base Robin host as well as for the container. And Robin is also integrated, can also be integrated with Prometheus and Grafana. That will allow you to collect any application stats and further analyze the data. Okay, so I'm over by around 3 minutes. Let me see if I have any more questions. Okay, how to build bundle on your own? Yeah, so Robin will provide training, bundle building training, and we have a bundle building guide that will help you perform bundle building on your own. So we have some standard reference bundles that you could use, and you could build. You can extend that based on your need. Okay, I think we are good. Thanks everyone for joining, and a special thanks to Charles for helping us on this. Thank you.